Good morning, ladies and gentlemen, and welcome to the SCT's 2017 Spring Lecture Meeting. First, to introduce myself, I am Paul Smith, Chairman of the SCT Lecture Committee, and I'll be chairing the lecture meeting today. Where's my dingle-dangle thingy? What's it gone? We have today our usual eclectic mix of lectures entitled Smoke and Mirrors with Glass. Can we use the tricks of technology to good advantage in fiber optics to provide the next must-have UHD formats, 5G, virtual reality and augmented reality? We shall see today. First, we have some housekeeping matters. Get used to that. Please note the fire exits. Please can you kindly switch off your mobile phones or set them to meeting mode. The meeting is being filmed, so please best behavior. We will take questions at the end of each session. There is a microphone as well, and we'll try and run around with that. The SCT cocktail party takes place at 5:30 in the Surgeon's Library. And we have some announcements. The SCT members can apply for bursaries for the FTTH 2018, the DVB World 2018, ANGACOM 2018, and IBC 2018. And the UK and Spring Autumn lectures for European members. The next few SCT events, as you can see for your diary, are Wednesday the 19th of April is the SCT Benelux Spring Lecture. Saturday the 17th of June is the SCT Gala Annual Dinner and Awards. Wednesday the 5th of July is the SCT Summer Lecture. And Wednesday the 4th of October is the SCT Autumn Lecture. Got a little note here that I need to read as well. Please note that the deadline for submitting your interest to the 2017 SCT Technological Innovation Award is the 28th of March 2017. So if you haven't done already, please send your interest to the SCT office, and we have the email address here this week. All those shortlisted are invited to attend the SCT Gala dinner on the 17th of June. As always, I need to thank our speakers who have travelled a long distance to be here with us, to the AV and the filming crew, and my special thanks to our Conference Papers Committee members, and especially to Sarah for her enthusiasm in arranging the agenda and juggling it around as well. So without further ado, let's start today's proceedings. For this morning, we have three speakers with some exciting topics: security in an unmanaged world, super agents, and the product of Sir C.V. Raman's optical discovery in 1928. For this afternoon, we have four speakers covering optical beat interference in optical networks, lessons learned from DOCSIS 3.1 deployment, LTE 5G challenges, and the evolution of distributed access architecture. Our first distinguished speaker is David Belt, Product Manager, Product Marketing Director, IRDETO, with a paper entitled Maintaining Control in the Unmanaged World. David is currently serving as a Product Marketing Director for IRDETO, where he's defining the next generation of content security solutions. David has been a specialist in cryptography and content protection for the past 20 years. With a strong foundation in the intelligence and defense community, David has spent the last decades leveraging his security skills to develop superior video experience to the cable consumer. Prior to IRDETO, David was heading up the important industry security initiatives as principal architect at Times Warner Cable and security architect at Cable Labs. He was also engineering manager at EchoStar, leading set-top box security and home networking technology. Dave holds a master's degree in system engineer from the Wright State University. Over to you, David. Thank you.
Good morning, everybody, and thanks for having me. So a few years ago, I did a series of lectures basically discussing the transition from conditional access over to digital rights management. These are content protection technologies that we use to protect our video, and they're addressing two very significant different video delivery solutions, going from a what I call a plant-to-home model to a more over-the-top model. Today, I'd like to kind of follow that in a similar vein, and let's take a look at the devices themselves and the devices that we're using within these contexts, and how do the actual security mechanisms these devices compare in the managed versus unmanaged space. So with that, a quick agenda. First off, let's talk about multicast versus TV everywhere kind of architectures, and exactly what are we trying to solve with regards to our security solutions. Next, let's discuss the operator-device relationship. We're going to find that this is very pivotal with regards to our security solutions and exactly what the operator's product offering is. And the device is the main portal into that. So this is going to become very important. Next, we're kind of going to go walk through some major security components that we've come to expect, and particularly in managed devices. And what do these look like in an unmanaged device, and how do we take advantage of those? Finally, we'll take a look at a multi-DRM solution, and in particular, what does that help us solve? We'll find that multi-DRM solutions will help us solve a lot of problems within the managed space, and this is now becoming a very significant trend within the industry. So with that, let's start off by taking a look at the landscape and just say, what problem are we trying to solve here? So for the past 40 years, cable industry has been delivering video via the plant-to-home model. This is similar for satellite. You essentially have some sort of video source up in your data center that is delivered into the household. With cable, it's obviously used a cable. With a satellite distribution, you're essentially broadcasting it. But ultimately, what the dependency is on this device right here. And that device is essentially regulating what you can essentially get access to and protecting that content from other people from getting access to it. Now, along that period of time, the internet was developed. Now, it didn't take long for people to figure out, okay, let's go stream video over the internet. And this now has created what we know as the TV Everywhere solution. We now have an expectation of our customers where they want to consume video anytime, any place, anywhere, on any device. And this is a very important distinguishing factor between our managed and unmanaged devices, and this is kind of what's going to drive our conversation today. But ultimately, we want to take a look at these devices, and essentially, what does this device have, and what are our expectations around it from a security perspective, and how do we get those security mechanisms implemented on an unmanaged device? Now, let's talk about the relationship between the operator and device. First off, the device is the operator's main interface to the customer. The operator is delivering a video product, they are delivering a video service, but they need that device in front of the customer with which to display it. Second of all, the user experience of the device is the greatest influence of satisfaction with the operator's product. So if you have an app running on, let's say, an unmanaged device, such as an iPad or an iPhone, ultimately, if your service goes bad, your customer has a bad experience, they're not going to call Apple, they're going to call you. So the way this happens within managed and unmanaged devices is very impactful with regards to what your service experience for that customer is going to be. Then third, and most importantly to me, is the device is the primary entry point for a potential attacker. So you now have this device that you're putting into somebody's living room that essentially has access to not only your video, but all of your back-end services. Similarly, on unmanaged devices, these are accessing these same services. So can this be used as an attack point into your systems? And also, how do we protect the video in your business model? So let's just do a quick comparison with regards to the actual management of these devices. So in a managed world, the operator more or less owns the entire system. They have a head end, they have content, they have cables going into the household, they have a set-top box, they own the system from end to end. This is a highly controlled environment that essentially we've gotten used to for the past 40 years as operators. On an unmanaged device, the operator owns a plant and an app. They have some sort of content distribution system up in the sky. This is pushed down into an internet that we may or may not own, and it's going to a device that we probably do not own, and you can put an app on this device to play your content back. However, you don't own the underlying infrastructure of this device. So this becomes a very different proposition. In the managed world, the operator typically has a high level of influence over the device manufacturer. When large operators buy set-top boxes, they do not go buy an off-the-shelf set-top box. They will engage with a set-top box manufacturer, and there will be significant customizations going into that set-top box from the silicon level all the way up to the user interface. So ultimately, even the chipsets within there will have unique configurations with them on an operator basis. So there's a very strong influence over that operator, and additionally, the content protections and the security mechanisms that they have access to are highly integrated and tightly integrated into these solutions. On an unmanaged system, the operator may have no influence over the device manufacturer. And in particular, when you're dealing with people like Google and Apple, you have very little influence over them. They basically say, this is your ecosystem, this is how you play within it, here, go write your app. So this is a very different proposition with regards to managing your video experience. Finally, the operator can depend on a significant access to system security resources. So we have, within the silicon itself, we have very significant security capabilities built into silicon nowadays. And getting access to that on a managed device, we essentially call up our vendor and say, okay, I want to implement this conditional access system, I want to implement this DRM system, and we just tell them to integrate it. And we essentially have the influence over those vendors such that we can get that done. On an unmanaged device, our security access is highly controlled and limited by the device manufacturer themselves. So within this device, we have a hardware layer, we have an operating system, we have various middlewares within there, and then on top of that, we're building our app. So all of that underlying stuff, we may or may not have any influence over, and we probably don't. So with that, let's dig into some of the security components and just say, okay, what have we come to expect on managed devices, and take a look at what that's going to look like in an unmanaged space. First of all, let's talk about conditional access. CA was designed for the plant-to-home delivery model. So again, when cable first came about, we had this idea of delivering television to the household. There's a set-top box in the living room, it's attached to your television, and you come home, you turn on the remote, and you watch television. This is the way it was 40 years ago. The idea of DVR, TV everywhere, any of these concepts were non-existent. So conditional access was built around this business model, the idea of being able to securely deliver video into the living room. One limitation of conditional access is that it expects a constant live connection to the device. So if we disconnect that box from the cable and the conditional access system is no longer connected, we're very simply not going to get content. Nobody ever had the concept of, hey, let's go take the set-top box out of the house. It's always been designed to be connected to that cable within the household. Third, conditional access has limited rights expression. Our TV everywhere use cases require the ability to have new consumption models that were never really thought about with regards to a conditional access model. So conditional access literally says, okay, you have subscribed to this sets of channels, and they're either on or they're off. Once we get to a TV everywhere model, we now have various new use cases, including download to go, content expiration models with regards to rentals, electronic sell-through, and the like. And conditional access in and of itself doesn't have the rights representation to carry this information within it. Some of the positives of conditional access are it has the ability to deliver security credentials in band. Now, I keep hitting that button, I apologize. In the in early days of set-top boxes, these were one-directional devices. You essentially had a data stream coming down, and we could essentially embed the keys within the data stream itself. And it did not require any kind of back-end service to go retrieve those credentials. So this was very designed, again, around the original cable model with regards to a unidirectional device. And this was actually kind of an advantage with regards to delivering credentials. Finally, there's tight hardware integration. As I mentioned, we have a high degree of control over managed devices and the vendors themselves. So therefore, if I say, I want to use conditional access A with your device, I basically say, go integrate it, and it's very tightly controlled with regards to the integration of the device. There are various standards out there that define the interface between conditional access systems and the managed devices. And so this is has essentially created a very tight integration environment, and as such, conditional access has very few breaches in it over the history that it's been around. So now let's talk about digital rights management. Exactly how is this different? Digital rights management was designed in the 2000s, which was in the time of the internet era. So we've already gotten used to the idea of, all right, we can stream content over the internet. Now how do we actually do it securely? So digital rights management is a more decentralized model that allows us to manage these use cases that I mentioned previously, as well as be able to consume outside the home. Digital rights management can operate even if a device is offline. So we can have a DRM client within a device, and if we want to download a piece of content, and I want to view that on television, actually one of the latest news is that Netflix now is supporting download to go for their service. And the idea that, okay, I can download this content to my device and take it with me is really an appealing proposition. In particular, people who fly a lot like myself. So, the ability to operate offline is spectacular. The DRM eventually needs to call home and verify the integrity of the licenses that it does have cached within its device. However, it does have the ability to go offline and still operate in a feasible manner. Third, it has a robust rights expression. Digital rights management is built such that in particular, a DRM license is very simply nothing more than a signed blob of XML code. So in that XML code, you have the ability to represent these various use cases, including download to go, content expiration, and the like. And additionally, these license structures are designed so that as we come up with new business cases, it's easily extensible. Now, I mentioned previously that CA could deliver credentials in line. Digital rights management, in general, delivers secure credentials via an out-of-band connection. So it may be pulling video from a CDN here, but it will eventually go to a DRM license manager to go retrieve a license along with the key sets to decrypt that content. The client, DRM client itself, is required to enforce the rights represented by that license with regards to if that content expires while I'm out camping and I'm not connected to the internet, I have to be denied access to that content going forward. So the content can still reside on the device, but the license will prevent me from playing it back. Now, this is the one that is going to be a bit of our hot topic and essentially makes unmanaged devices a little bit more unwieldy. And that is that hardware integration of digital rights management on devices is highly dependent upon the client implementation. So if a device manufacturer chooses to integrate a DRM on their device, how they integrate it, or if you are using a DRM that's not native on the device, this can essentially soften your security capabilities based on how this is implemented. And we're going to get into some of those details here in a little bit. Secure video pipeline. If you've ever looked at programming agreements from the content providers, this is a common legal phrase that frequently shows up in them. And ultimately what secure video pipeline means is, okay, I'm delivering encrypted video over some link, whatever it is, to this device. When it gets to the device, it needs to be decrypted, it needs to be decoded, and it needs to be rendered to a screen in a manner such that A, that video is not exposed, and B, the keys associated with that video are exposed. So therefore, this creates a big black box where all of this has to happen. In managed devices, in particular, we've become highly dependent upon the fact that our SoC, when I use the term SoC, silicon on a chip, or system on a chip, is the actual chipset within these devices. Within there, they actually have a secure micro such that the video goes into there, it is decrypted, decoded, goes to the video decoder, and it's sent to the video output, such that if I were to actually break a device, put a debugger on there, I would not be able to actually see the video flowing through there. So this is embedded deep down within the hardware such that we can't see this. On managed devices, we've also seen the evolution of what we call white box cryptography. This is the idea of using obfuscation technology to essentially create this pseudo black box similar to this hardware box. And it allows you to do secure operations in a software manner. And we'll talk about that a little bit more in another slide here also. So let's do another comparison here from the perspective of content protection. So on the managed side, we've been using hardware CA that's cryptographically coupled with the hardware of the decoder very tightly. As I mentioned previously, it's this coupling that has made CA very robust for a long time, and conditional access has very few instances of actually being broken. On an unmanaged device, a hardware decode requires the use of what we call the native DRM. So if Apple decides to go manufacture their device and they want to put a DRM in here, and I'll tell you right now, Apple only supports one DRM, and that's fair play, it's their own. The only way to actually get access to the hardware engine on this device is to use FairPlay DRM. So I can use other DRMs if I so desire. I can do a Widevine implementation or an Adobe implementation on an iOS operating system, but it's going to have to be done within a white box cryptography implementation. You're not going to get access to the hardware engine on this. And this is going to be, again, this is kind of where the theme's going with regards to the trick around unmanaged devices. Next, downloadable conditional access has become fairly popular. And essentially what this is we can download a conditional access system to the device, and we're using the underlying SOC's hardware engine, which has some sort of standardized interface to it, to actually to do the actual cryptographic operations and link into the video pipeline. This allows us to, essentially have downloadable. The vendor can break themselves from CA dependence to a particular vendor, and as long as there's an underlying standardized structure that they can utilize, that the conditional access system can very simply bolt onto that. As I mentioned previously, on unmanaged devices, we have sort of a flexibility to the system where we can essentially switch DRMs to our heart's content. However, if you're going to vary from that native DRM on the device, you will have to use a white box solution in order to protect your content and your keys as they're passing through there. Again, on the managed side, we have limited rights representation, so our use cases are limited with regards to what we can do with this video. Again, we're sending it into the household, and that's basically what we're getting. And on the unmanaged side, we do have digital rights management, so therefore we have a robust rights representation, which allows for our TV everywhere implementation. Now, specific note, and we'll get to this a little bit later too, high-value content may require hardware decode. So the programmers, our content providers, the guys who are providing this high-value video, in particular once we get to 4K, are going to require that this goes through a hardware pipeline. I can tell you right now there are many implementations out there right now that are delivering standard def and high def video through white box implementations. But the ultra high def, a lot of the expectations around UHD are taking that up a notch, where there's going to be some expectations around more hardware implementations. Let's talk about root of trust. This is another common term that you'll find in programming agreements. So what is root of trust? Root of trust is a cryptographic credential that serves as the device identity within the device. Anytime that you're going to be delivering content to a device, you have to know what the device is, who the device is, and whether it's authorized to get that content. Ultimately, the root of trust can be implemented in two different ways. You can design the device in a factory, you can embed some sort of secure credential in the hardware itself, and then that's permanently tied to the device. On a software implementation, let's say you have a software DRM that's implemented with Whitebox, the first time you fire up that DRM, it's going to go to a personalization server, and it's going to retrieve a credential that's going to be used from there on forward with your device for that DRM system to authorize it. Clearly, you can see in between these two, if you're putting a credential into a device in the factory, it's a very different proposition than going out onto the internet to a server to go retrieve a credential. So obviously, the term hardware root of trust is only going to be available when you use a native DRM on the device. And again, if you're going to have increasing programming agreements and the content provider saying, okay, this content has to go through, have a hardware root of trust, then we basically need to use the native DRM to do that. Let's talk about secure boot. So secure boot's been around for a long time on managed devices. And the idea is that when I burn a firmware image into that device and the device boots up, the hardware itself will literally do a signature check on that binary image and verify that that is exactly as it was supposed to be. So it's been signed by me, the software developer for the operator, and the device can essentially verify that this is the software image that we put in there. What is this doing? It's preventing people from taking over our set-top boxes is what it's doing. People can take your set-top box, write a different piece of software, and repurpose it for whatever they want, in particular stealing your video. On unmanaged devices, you have a secure boot in here, but Apple's protecting their stuff. So they've essentially signed their operating system. They've signed, all of their firmware images, and they're essentially verifying the integrity of their device to keep it moving. They don't care about your app so much. When you write an app, you put it up into the Apple App Store, there will be a digital signature on it there, but ultimately what's going to happen is it downloads to your device, it verifies the signature just to make sure it didn't get corrupted along the way, and that's the end of it. Once it's installed on your device, it won't check again. In a managed device, every time you boot that device, it's going to literally verify that firmware image to make sure that you didn't go in there and hack the code to do something other than what it was intended to do. So this is arguably one of the biggest gaps within managed devices that's not covered currently, and there's not a lot of ways around it. But we do have application tools that can essentially do other things at our application layer. We can essentially verify runtime app security, we can do obfuscation within those apps, and we can create additional security within them. But ultimately, the secure boot piece of this, again, it's representing the device. It's not necessarily representing your app or service. So a quick couple comments on obfuscation technology. And this is, again, when I'm referring to white box technology, this is what I'm talking about. But ultimately, what obfuscation technology does is it takes your code and it scrambles it into spaghetti, and it essentially makes it infeasible to disassemble. There's a trade-off to this. When you do this to your code, you're essentially lowering your performance of your code, but ultimately, it does allow you to do a lot of secure things within a software space. This is frequently used when hardware security engine is not available. So again, this is very popular on Apple devices right now for those who are using any DRM other than Fairplay. So ultimately, in order to do this, you take that DRM, any of your secure operations are obfuscated, and that's essentially how we're protecting them within a software space. This may or may not be acceptable under certain programming agreements. And again, With standard def and high def content, we're streaming a lot of video to white box solutions right now. But UHD is definitely going to up the ante on this. And then finally, even if you do have hardware implementations, white box is still used at a lot of the interface points. So for instance, you have this software components that's interfacing into the hardware engine of the SOC itself. You may obfuscate around that such that you can't actually see the calls going in. Additionally, you may obfuscate calls that are going to your back-end system. You may not want to expose your APIs to a potential hacker, and this can be used as an attack point into your back-end. So ultimately, obfuscation in those particular instances will continue to be prevalent even if we do essentially achieve hardware bliss with regards to hardware decode. So where do we go from here? What are the big drivers of our security requirements as of this point? UHD is the #1 right now. So the emergence of UHD technologies are calling for enhanced security requirements. In the UEPS, we have what's called the Movie Labs Enhanced Content Protection Specification. And this specifies some, very blatantly, some additional requirements that we've been sort of skirting around for a little while. One of them is a hardware video pipeline that outright rules out using white box cryptography to decrypt content. So this ultimately says we need to have access to that hardware engine on that device. Second is hardware root of trust. We talked about root of trust. That root of trust has to be embedded with the device. We know that it has to be cryptographically tied to this in order for us to be able to deliver this type of content to it. Third is watermarking. This is a different lecture that I'm using to pitch myself for the next conference. Yeah, I don't want to go into watermarking too much. It's a completely separate lecture. But yeah, this is one that is a sticking point for a lot of people right now. Do we need to watermark content or not? And you know, the implications of it are fairly significant with regards to operators. So the punchline to this, the only way to meet these requirements on unmanaged devices is by using the native DRM. Whatever DRM that the device manufacturer embedded into this, tied it into the hardware engine, and they are exposing it to you via APIs and other ways to get access to it, but you have to use their DRM. So in order to be able to deliver 4K content to, say, an Apple TV, you're going to have to use Fairplay DRM in order to do it. So with that, let's talk about multi-DRM. This is kind of just a rough landscape. This isn't all the devices out there, but it sort of tells the story with regards to how multi-DRM works. Let's talk about Widevine. Widevine was a small DRM company that was bought by Google. And they're now kind of a big DRM company from the point of view, they're now being embedded in everything that Google makes, in particular Android, Chrome devices, Chromecasts, and the like. So Widevine has a very large breadth with regards to accessing a lot of devices. Then there's PlayReady. PlayReady's biggest claim to fame is they've probably been around the longest, and therefore on the most devices. They've essentially had the most complete solution, and therefore has a lot of penetration within devices. It has some peculiarities with it, in particular to the way the licensing structure works, and also the way the licensing agreements for the operator work with the technology. But ultimately, Microsoft has quite a broad reach as well as Widevine. And in particular, these two DRMs will give you large reach within your device management community. Over there in the corner by themselves, we got Apple. And you know, Apple's always doing its own thing. And again, they have their Fairplay DRM, and no other DRM is going to play on their device like we want it to. Over here we have Adobe. Adobe has, anybody who's using Flash Player nowadays, you can use Adobe DRM with that. There's a couple large deployments in the US at this point of Adobe DRM, and in particular they have a default implementation in the Firefox browser. So Widevine has also been implemented into the Firefox browser at this point, but in particular Adobe does have a good amount of breadth within that kind of space. Finally, we have Marlin. I'll be honest with you, I personally haven't used Marlin. It's not terribly popular in the US, but it is more popular in the US and in particular in Asia. And I do know that Sony does love Marlin in particular to use on their devices. So these are mostly the DRMs that are going to get you your breadth. A lot of people will say it's like, okay, if we have Widevine and we have Play Ready and we can accommodate FairPlay for our Apple devices, that allows us to pretty much reach any device that we want. Now, that's the DRMs. Then we have the transport underneath it. So we still have this bifurcation between HLS, which has been historically solely an Apple thing. Everybody's essentially adopted HLS because it is a working specification. It is a great way to deliver content, but Apple owns the specification for all practical purposes. MPEG-Dash is a reaction to that from the point of view of creating an internationally standardized video fragmentation mechanism. And MPEG-Dash has this sort of overlying promise such that we can do common encryption. And the idea here is that, okay, I can encrypt one piece of content and I can serve any one of these licenses off of that content. So we would have a common key server in a multi-DRM system. I can essentially send that key to a Widevine license, I can send it to a PlayReady license, and with any luck, we might get Apple on board, and we might be able to serve it to a FairPlay license also. But they're not quite there yet. There's a controversy between Microsoft and Apple with regards to common encryption technology. So, as you can imagine, we'll see if that actually comes to pass. So, in summary, video delivery is rapidly migrating from a plant-to-home delivery model to an OTT model. If there's anybody here that didn't know that, we've got a bit more of a problem. But yes, this is the direction things are going. People want their TV everywhere, and the plant-to-home model is essentially becoming more archaic with time. Unmanaged devices presents a new set of security challenges to the video operator. Again, we don't have control of these device manufacturers, and we have to play by their rules, but there are ways to do it. In particular, use the device's native DRM. It's been integrated properly. The device manufacturers know that you have to be able to deliver video to this device securely, but ultimately they're going to be doing it on their terms, and you have to adapt to those terms. And finally, a multi-DRM strategy is required to achieve the greatest client reach. We have lots of devices out there, and ultimately, to be able to reach those, we will be required to go to a multi-DRM model, and this is the ongoing trend at this time. And with that, do we have any questions? I just holler it out.
Okay. Very interesting lecture. Thank you very much indeed for that really good summary of where GoIM is. You mentioned MPEG-Dash and the Apple-Microsoft alignment at the end. Maybe you were alluding to CMAF at that point?
Yeah, so CMAF, yeah, so CMAF is kind of an extension of Dash. That slide should actually be updated with that, thank you. But CMAF is essentially an effort mostly between Microsoft and Apple to essentially bridge that gap within the Dash community. So Dash essentially started out as a specification this large, and CMAF is kind of paring that down into a more implementable standard. And this has been ongoing between Microsoft and Apple. And in particular, the hang-up at this point is what we call the common encryption scheme. And Apple is hung up on CBC mode, which is called cipher block chaining, and Microsoft is hung up on counter mode. And both of their security experts in each of their departments essentially have staunch reasons for not going with the other encryption mode, but they won't tell anybody. So they always say, we want to have a conversation around, common encryption, but they won't actually tell what their reservations are or what the attack vectors are into the other one's encryption. So it's been the stalemate for some time. And we have some rumors, actually Rodrigo just wrote a blog on this the other day, there are some rumors that Microsoft is potentially going to cave over to CBC mode, at which point then we can truly achieve a common encryption kind of mechanism. Anyone? I wasn't that thorough. Well, thank you, everybody.